In this video, we're going to be talking about how to combine like terms in order to simplify an expression. Let's take a look at how we do that. We need to know a few things. First thing we need to know is, what is a term? A term is something that is separated by either addition, subtraction, or equal sign. So if I said 2x plus 5, how many terms are in that? Well, the 2x is separated from the 5 by addition. So those two separated things are my terms. So 2x is a term and 5 is a term. All right, now in situations where there's multiplication and division in it, remember multiplication and division do not divide up terms. I got to do that before I can figure out how many terms are in it. So if you look at 2 times the quantity of 5 times x plus 6, okay, I got to do that 2 times 5x first. So after I do that, I get 10x plus 6. Again, this only has two terms because 10x and 6, they're separated by the addition. They're each a term separated by addition. All right, so let's talk about how we know when things are like terms. Okay, so to be a like term, you have to have the same variable and the same degree of power. Also, constant terms can be like with one another. A constant term is a term with just a number in it, no variable. So if I was looking at 2x minus 3x squared plus 5, I see that I have three different terms, 2x, 3x squared, and 5. So if I was going to see if there are any like terms in there, well, the 2x could only be like to terms with an x in it. There is the negative x squared, but that one has a square, so it has a different degree of power, so they're not like. All right, and the 5 can only be like to terms that do not have a variable in it at all. So actually, then these three terms in this expression, none of them are like with each other. Let's look at some examples that I'm going to show you. That way you know how to combine them after we've identified what is like and what is not. Okay, so we're going to do some examples of combining like terms because there are a few more steps I haven't talked about that we need to know. All right, so when we're combining like terms, we always take the sign in front of it. Okay, so when we were in elementary school, we learned that there are addition and there's subtraction. Okay, now that we're starting pre-algebra, the secret's out. Addition is the same thing as positive. Subtraction is the same thing as minus. Just like sometimes we use a different word, but it has the same function, just sometimes it functions as a noun and sometimes it functions as a verb and the word is slightly different, but it means kind of the same thing. We have that same thing going on here in math, all right? A positive and an addition, they hold the same symbol, okay? But depending on what capacity we're using the numbers in, we may use a different word, okay? So when we're talking about the sign assigned to the number, we're talking about positive and negative. If I don't have anything, like I don't know if this 2x is positive or negative, well, we just assume it's positive, okay? So these are my different terms. I'm going to put a box around my term with their sign. So it's always the sign in front. Okay, so my two that are like are this 2x and this 5x because they have the same degree of power, same variable. We are good to go. All I do, okay, when I'm adding these is I add the coefficient. So coefficient is the number in front of the variable, okay? So that's your 2 and your 5. I just add those and I get a 7. And then I take along the thing that is like. Nothing is like with the 10, so I just drop it down. Okay, so I get a lot of questions. Why don't you do anything with those x's? Why doesn't it just come out as x? There are two ways I can explain this. Number one, it's a pattern in math. When we add fractions, okay, let's say I add these two fractions. I add the tops, and the 2 just is along for the right. The reason is because I'm adding the thing that is unlike. But the thing is that is alike, which in this one it means 2 whole parts make a whole, is just along for the ride. Same thing here. The x is what's like, so it's just along for a ride. The other way I can do is remember that all of multiplication is actually addition. So this says I'm multiplying 2 times x, which would be 2 x's in addition. This would be 5 x's in addition. 1, 2, 3, 4, 5. So if I add up all the x's that I have 7 x's. Okay, we're just going to quicken that process by just adding their coefficients and bringing x along for the ride. Okay, so let's look at a tougher one. All right, let's say we have this equation. So now we have multiple things that are like, they're all over the place. We got to rearrange them together. So again, I'm going to assume that's positive because it doesn't say it's negative. So this is like with this one because they have the same variable, same degree of power. So I'm just going to write them beside each other. Let me change my pen color. This one is like with this one because same variable, same degree of power. So I'm just going to write them beside each other. And lastly, this one is not like to anything. So I'm just going to put a plus 10. All right, so let's get our like terms together. Remember, all I'm doing is adding the coefficients, okay? So 2 minus 3, or 2 plus a negative 3. However you like to say it, it means the same thing. It's going to be a negative 1, and the x is along for the ride. A plus 5 minus 2, or a positive 5 and a negative 2 are going to make a positive 3x. Remember, since we're adding and subtracting, we have to put the signs of every term. Even this first one if we like, but remember, if it's positive, we can leave it off. The 10 is not like with anything, so it just drops down. Now, there's something I want to show you here. If you decide I don't like my negative out front, you can rewrite it like this. This means the same exact thing, because look, I brought the sign with each term. So I didn't really change the meaning of the term. I just rearranged it, and you were totally okay with doing that. That goes back to your math rules, the associative and the commutative, how you can move things around as long as they don't break the fundamental rules of math. All right? So let's get a little bit harder. So we said that you have to be done with all of your multiplication before you do anything, before you combine like terms. Right here I have some multiplication. Remember, I can show multiplication many different ways. One of them is with a parenthesis, or just putting two things beside each other. 2 beside an x is also multiplication. So this is multiplication and this is multiplication. I got to do that first. After I'm done doing all my multiplication, I see, yep, they have the same variables, same degree of power. I can combine them. So 6 plus 20 is 26, and the x is along for the ride. Let's try another one with some division in it. So I'm going to put okay, so just like there's different ways I can, do multiplication, there are different ways I can do division. I can do division this way, I can do it this way, I can do it with a slash, and I can do it with a fraction bar. A fraction is actually just a fancy division problem. Okay, so how many times can 4 go into 20? That would be 5. Bring down my x. How many times can 8 go into 64? That would be 8. Bring down my x. I have 2 like terms here. They're both like with each other. The 5x has the same degree of power and same variable as the 8x. So I can combine them and get 13x. Okay, so then we have this, okay? So if I'm following all my rules of math, I also have to follow order of operation because that's the organized method of which I do my math, okay? And that says I do parentheses first. I can't do what's inside these parentheses. These aren't like terms, and these aren't like terms. So I can't do what's in the parentheses. I can't add the numbers together. Now, I showed you that there was another thing that parentheses meant, and that's multiplication. So as you can see, this 3 is actually multiplied to everything inside of the parenthesis, and this is called the distributive property. Okay, and that's what I'm going to show you. Okay, so when I do this, I take the 3 times everything inside the parentheses. So it has to be times by the x and it has to be times by the 5. All right, and the same thing here. The 2 has to be times by the x and it also has to be times by the 3. All right, now I'm going to do, remember, I have to do my multiplication division before I can get my like terms together. So 3x, 3 times 5 is 15, 2x becomes 2x, and 2 times 3 is 6. Now I look for my like terms. Well, this is understood positive. That is like with that one. So I have 3x plus 2x, and this one is like with this one. So I have 15 plus 6. So now I get those coefficients together and let that x be along for the ride. So 3 plus 2 is 5x, and 15 plus 6 will be 21. That's as far as I can simplify that because 5x, 21x, they're not like terms. So they just stay there. All right, let's do one with some negatives in it, okay? So what if I have this, okay? So in this one, again, I got to distribute it through, all right? So, but remember, I always take the sign in front of things when I'm doing it. So I'm actually taking a -3 through this first one and a -2 through the second one, all right? So I'm going to put my little parentheses there so that I'm not getting all confused with my negative. I'm going to take my -3 and times it by the x, and I'm going to take my -3 and times it by the 5. All right, in this next one, I'm going to take my -2, okay, I'm going to times it by the x. The x is positive, so I'm going to put a positive there. Then I'm going to drop down the negative, and I'm going to take a -2 times the 3. All right, so this is a -3x, okay, plus these two multiplied together is going to give me a -15 plus -2 times x is a -2x. Drop down my minus. A -2 times a 3 is a -6. Now I got lots of double negatives. If you're taking a rational numbers course, you know we gotta do something. We can't have two signs beside each other. The plus and the minus are usually not a big deal. We can usually keep those. A lot of people like them cleaned up though. Should never have two signs beside each other. So I could just make that a minus. The minus is stronger than the plus, but it doesn't matter. I'm going to keep it in just because it usually doesn't bother people. This is the one that bothers people. When I have two negative signs beside each other, that is a plus, okay? And check out a video on integers if you don't know how to do that. That's not really what we're going over today, so I'm not going to go over it. All right, my like terms. Okay, -3x minus 2x, and then this is like with this, right? So minus 15 plus 6. Look, these extra ones, they kind of got forgotten about anyway, so that's why they don't matter. Okay, -3 minus 2 is, and I'm going to come up over here, a -5x. -15 plus 6 is a -9. That's the furthest that I can simplify. All right, so that was my examples for today. Check out some of my other videos. Subscribe to my channel. Do all kinds of cool stuff. check out my blog, all that kinds of things. I have a tag next that will give you all the information. Hopefully you've learned something today. If you haven't, please put it down in the comments, and then maybe I'll make another video if there was a step that I assumed you knew in this video. So good luck, happy math, happy doing math, and I'll talk to you all later.